I think I nailed it, right?
An electrical installer like that earns between 6,000 and 8,000 zlotys.
Today on the Do Roboty channel, we're at the rolling stock maintenance facility of Wielkopolska Railways. But today we won't be talking about the railway, we'll be talking about the photovoltaic installation by Unimod Energia i Gaz. So there's a lot going on, and with me is Wojtek. Hello.
Hello Wojtek, welcome.
How is the installation going here?
Listen, we're still in the middle of construction. We're building carports, carport shelters for cars, for employees. In the same way, we adapted a railway embankment here, which was an unused mound with a special root-based structure also adjusted to its slope. We installed panels here. However, as you can see behind you, the modules are already prepared. There's a roofer's lift ready, so we'll also be working on the roof today. And besides that, we're also expecting a delivery of the energy storage today. So I think there will be quite a lot going on. I'm glad you came, and at the perfect time.
I've already completed the health and safety training, so let's get to work. Let's begin the energy storage installation since the door is waiting.
The crane is waiting, so let's go.
Let's get to work, it's waiting.
The energy storage serves two functions. The first is to collect the excess production from the panels so that it isn't wasted or sent back to the grid. It stores it inside itself, while the second function, which is very important, is to protect critical circuits. So it's like a UPS. It will protect our lighting, it will protect our IT networks, which is incredibly important in the case of this facility. Because even without heavy machinery and so on, thanks to this storage, the work will still be able to continue.
Okay, this kind of energy storage, is it later somehow enclosed, or is this device we see here simply what's installed here?
This storage is freestanding and has proper protection against weather conditions. There will also be a special foundation for it, through which cables will be routed and which will also help with its ventilation.
The capacity of such a device?
This storage unit has a capacity of 215 kW, which, to put it simply, means that an iron that uses 2 kW could run on it for over 100 hours.
On it when it's fully charged?
Alright, of course, that's not how it works. It has a converter inside with a power of 100 kBars, so theoretically, if we ran it at full power, it would last for 2 hours. We will make sure that in case of a power outage, there will be lighting, which means safety, and there will be IT systems, which also means safety plus communication. I'll show you what's inside. Jesus.
What heavy doors?
Yes, listen, the doors are heavy, but not because they're armored, but because we have air conditioning installed here. It serves two functions. It heats in the winter and cools in the summer. That's because the battery cells have to operate in optimal conditions. The point is to extend their lifespan.
So that every viewer can understand, both the youngest and the oldest. Photovoltaic panels produce direct current.
Direct current, the same kind we have in car batteries, in regular batteries, direct current. It goes to the inverter and the inverter turns it into alternating current, the kind each of us has in our outlets, that's right.
Direct current goes into such a battery again.
Yes, and that's exactly the difference. We have a battery converter that can charge the battery with direct current from the grid and then convert the direct current back into alternating current. So we have energy flow in both directions.
And also, just so everyone understands the comparison, are these, I don't know, gel batteries, or like the ones we have in cars, or like the ones in mobile phones?
Kind of, yes. Listen, the technology has also evolved. Here we already have lithium-ion batteries. Yes. So, the kind you find in laptops and phones.
It's installed right next to the transformer, so the wires from the transformer connect directly.
Exactly.
In both directions connected.
Yes, of course there will be protection along the way because we don't connect it directly. There will be protection. Here we also have the issue related to the network operator, who also wants to have some control over it. And a lot, yes. There is some automation and metering so that the power company can see what's happening with it. So that's another indirect aspect. And then we go to the transformer station with the main power supply. However, for the circuits we want to protect, there's an additional output, the so-called backup outputs. And these circuits will be additionally protected against power outages in the network.
Today we'll discuss this type and show an installation you might call industrial. But if someone wanted to install such an energy storage system at home, is it our electricity that we generate ourselves? Or is it like, yes?
We can say that it's our electricity. Although all these devices basically work on the grid, meaning they're connected to the grid, they have the ability to work, just like you said, as a UPS. But everything we produce is ours. So we don't pay taxes, we don't pay transmission fees, and so on and so on. We're not interested in what the rate is on the grid. It's ours, we use it for our own needs. This is what's called self-consumption.
Let us know in the comments if you have an energy storage system at home or have considered one. We'll read and reply to all comments. Anyway, let's pack up the equipment and see the photovoltaic panels and installations since there are so many here. We'll go up on the roof, show you the carports. There's a lot to see. Stay until the end of the video. Everyone knows about photovoltaic panels on roofs. Most people have them, but what can we say about these carports?
Well, listen, this topic is related to the fact that we're looking for slightly different solutions here. Obviously, everyone knows the systems on flat and sloped roofs. That's pretty standard by now. However, in the case of such industrial installations, for clients who are looking for every square meter of space, we're looking for unconventional solutions. A carport, besides not taking up space, also gives us additional functionality. Because look, here where we're standing in this one bay, 2 cars can fit. You get into a car that's not overheated. It's not icy, there's no snow on it, so it's more comfortable. These carports we have here actually have a bit of an industrial style form.
Yeah, that's how they look, pretty rough if I can say so. So it's just bare metal.
It's bare galvanized metal and it's supposed to be durable, tough and do its job. But there are also carports for people like us. There are a lot of possibilities. We can make carports with lighting, sealed, with semi-transparent panels, which we also produce at our company. We can add drainage. The possibilities are much broader. And we're not just limited to the name carport. We can also make pergolas next to the house where you can have a small pool. We have a really nice project like that.
But is it really worth it in the end? Because let's say on a carport, pergola or whatever, we have, I don't know, maybe 5, 6 or 7 photovoltaic panels. The cost is probably quite high. Calculating it, let's say over the payback period.
There are already enough similar solutions on the market and module prices have dropped enough. Although it may not seem like it, this carport isn't much more expensive than a typical ground installation. Considering its extra benefits, I believe it's a great investment. Because if you were to build a garage or a carport and then install PV next to it, it suddenly turns out that you have something that will pay for itself in 7 or 8 years.
Right? And it's all combined in one place. Yeah, that's right.
Yes, let's assume that in Poland, under good conditions, from 1 kilowatt of power, so let's say from 2 such panels, we are able to produce about 1,000 kilowatts of energy per year. What matters to us is that the sun shines on the panels, right? So the tilt was in that direction.
Previously, everything was planned in the design office to ensure all parts fit together and that 2 cars could still fit underneath.
There's nothing random here, right? If the ground here was, I don't know, clay or some very tough terrain, then we wouldn't have done this. That's why, before we even started thinking about this, soil tests were done. Based on those tests, we did the calculations. It turned out that this system would easily hold up.
So we have the last panels to install on this carport here. Yes.
We need to set up our scaffolding. The beams are already prepared. The mounting brackets are set up. We'll position them directly over the holes and fasten them with screws, tightening them to the proper torque. We're using a torque wrench which allows us to set the correct torque. As we can see here, it's 50 Newton meters, and when tightening it will signal us when the screw is properly tightened with an audible sound. I think
That's it.
we have the module installed. Now all that's left is to tighten these screws.
But it looks pretty straightforward and simple, doesn't it? Just like building blocks.
This work is very schematic, right? One after another, like a domino effect. The visual effect is also very important. It's the most important thing during inspections or for the investor, right? Because even though the investor knows it will work, he also looks at the aesthetic qualities.
If you're spending money, it's nice for things to look good. They come from the factory with cable ties and wires attached, so we just connect them following the diagram.
Exactly. You also have to remember that the cables can't be tied too tightly because it's rubber, there's insulation on the cable, which contracts in the cold, but then in the summer expands. We can connect them together first. You'll hear a characteristic click. Exactly.
Yeah. Well, I would rate myself at about a 3+. What do you think? With a slight plus?
It takes a bit of practice. With 20 or 30, it would definitely be better.
There are many photovoltaic panels here and installation is underway. You can see workers in the background, but it's not like a crew of 20 or 50 people is needed. I'd say there are about 10 workers in total here.
A standard construction, let's say up to 500 kilowatts, up to 300 kilowatts, about 8 to 10 people is enough.
And the time for the whole installation, from the installation on the roof through the carports to the photovoltaics here on this slope.
Not counting the preparatory part, meaning the designs, the studies, all the things I told you about. The installation itself takes about 6, 7, up to 8 weeks here in the case of this facility.
Looking at the people here, I'm not sure, are they power engineers, electricians, or installers? What should I call them, or what are their roles? Listen.
For these installations, we combine roles, a bit of steel structure installer and a bit of electrician, since most of the work involves the structure. And here, this knowledge, even basic knowledge of using power tools, of using hand tools, measurements and so on, that's the mechanical part, right? But later, after installing the panels, we get to the electrical part. That means connecting everything, cabling, distribution boards. So you could say that a worker who wants to work in photovoltaics, who should work in photovoltaics, should combine these two things a bit. And if not, then it's good if in a team of, let's say, 5 or 6 people, there are a few people with more construction experience and a few electricians. These roles come together beautifully.
So how much does an electrical installer like that make after just such a short training? So a person who isn't that experienced yet at work, not someone who solves all the problems, just let's say someone who does this kind of work, how much can they earn here?
The salary range is very wide. They have also changed over the past few years because photovoltaics grew very strongly, then it dropped a bit, now it's growing again. But an electrical installer for this kind of work earns between 6,000 and 8,000 zlotys.
And here, this is field work for you. These are business trips. What does a 6 to 8 week installation look like?
We work all over the country. And recently we also started working outside of Poland. So our employees, of course, have their business trips paid for, travel and so on. And all of that is somehow managed financially.
Sure, so that's also information for the viewers. If you like, let's say, working on business trips, then you might be suited for this, because here it's hard to say you'll be working in one place since the installations are all over Poland. And as we hear, also abroad. So be sure to let us know in the comments. Do you prefer this kind of stationary on-site work? From a certain hour to another with a commute home? Or maybe you prefer working on trips? Be sure to write about it. And now what are we doing? We're putting on our gloves again and we're getting back to work. Yes.
We have a root system here. First we had to prepare the whole area. There was a lot of vegetation here and a big curve. We shaped the terrain. There were geotechnical tests which came out positive. We've already installed several supports here. We checked it and it's holding up very well.
So the advantage of this root system here is that we don't have to pour, I don't know, concrete blocks, lay them out and so on. No. So what do we install? Show us what it looks like.
Here we have the base and it's driven or shot in at a diagonal.
And it creates a kind of root. That's right, it does. How long is this? A meter?
1.20 meters.
This anchor is 1.20 meters long. So what? We put the pipes in here.
We put the pipes in.
And they don't have some kind of pointed end or anything?
Or something like that. Here it's flattened and that's where it goes in. And here's the range to the end, right?
Honestly, this is the first time I've seen a system like this. Comment if you've seen something similar before. Usually when you install something into the ground, you do a concrete pour, put in some formwork, and that's how it's installed. Interesting, but you say these panels aren't heavy, right? The structure probably isn't that heavy. The only concern is a gust of wind could lift it. Yeah, but with this installation and nearly 1.5 meter anchors, it's unlikely to come out of the ground.
It slides in easily, that's right.
But what do you think? We nailed it pretty well, right? Very well.
For the first time.
For the first time, is the nailing perfect? Okay, let's nail it. We can nail it?
That's right, we're hammering it in.
All right.
I like it.
What do you think?
By the 70th or 75th, my hands would probably shake, but the first one is fine. It's cool. I recommend it. Once installed, you can see it's stable. Are we doing the next ones? Yes. All right, is it my turn?
I have one too.
So we have to do it together, right? Exactly. There's no other way. All right.
Thanks.
All right.
Still there.
And here I can just see that most of the elements are well made here, cut to size so that everything is even. But for example, the photovoltaic panels were standing on pallets. Can you buy them from you somehow, or how does that work?
Yes, we have our own online store. Anyone can freely go in and see our products and easily order them to their home even.
Okay, so you can order these products both retail and wholesale. Yes, we'll add the link in the description. If you're interested in photovoltaic installations of any size, check there. We'll continue installing since there's not much left. That's right. We went upstairs with Mateusz. It's a rather unusual photovoltaic installation on the roof. What can we say about it?
It's quite an unusual structure because it's welded directly to the roof surface, which in this case is covered with roofing felt. Thanks to this, we can carry out such installations on roofs that have lower load-bearing capacity than standard ones. Yes. We don't need to additionally weigh down this structure with ballast or extra load. Instead, we attach it directly using a torch. The metal plates are welded directly to the roofing, which makes them much more stable, and the pull-out resistance is at a much higher level. However, underneath, as we can see here, there are square pieces of roofing felt welded under the panels. Underneath them, there is a metal plate designed for this purpose with a protruding bolt, which is attached directly to the cross purlins.
So, if I understand correctly, we can install such panels or such systems on apartment buildings where the roof is flat and then use something like this. I also see here that the panels are set up on both sides.
Yes, the panels here are set up facing east and west, which allows them to produce energy much more efficiently, and we can then use it for self-consumption. That means the eastern part works more in the morning hours and the western part works more in the afternoon. So the production peak, like with a south-facing installation, the peak is highest at 12 o'clock, but with an east-west setup, the production is spread out more evenly throughout the whole day.
Are these connectors already attached to the panels? Are they universal for all panels, or do they vary?
They can differ. There are different manufacturers. There are round versions, there are square ones. But here it's on us to adapt our MC4 connectors to the ones installed by the manufacturer.
Okay, let's leave the panels as they are, but we'll need to terminate the cabling along the cable trays ourselves, just like we just did here. This cable is specifically designed for photovoltaics.
Right, yes, this is a cable for direct current, for DC power, which has a special insulation. It's specially prepared, and there's a standard that specifies how this cable should be manufactured. Here we have the end of the entire string of modules that were previously connected, and here we connect them directly to the wiring, which will lead us directly to the inverter connection. And of course, along the way, we also have protections that secure the entire installation before the inverter, for example, in case if a situation like a short circuit were to occur.
Wojtek, we're almost done with the work on these photovoltaic panels, this whole comprehensive installation, but I don't think we'll be connecting this train to it just yet. No, what are the next steps?
Well, there's still a bit ahead of us. We're finishing construction and assembly, connecting everything, checking and measuring to ensure safety before moving on to the next phase. The energization process, which means connecting our beautiful installations and the storage to the grid. We call it connecting to the grid, even though we use most of that energy here on site, but the grid also has to be connected. Along the way, before our connection, there's still the power company. We have to set up a station with automation and metering so they know what's happening and can control it. Only then, after these activities are completed and after the power company has inspected it, can they connect this installation to the grid, so to speak. We can also buy this energy back from them, and our company Unimot Energia iGaz also provides such services, meaning it sells Pro.
So you both sell and buy this energy?
That's right, that's right.
So we can both buy it from you and sell it to you if we have, let's say, a so-called surplus, because obviously anything we don't use or anything we don't store goes to the grid, so we can sell it to you.
Normally this is done by the network operator who is here, but we can also offer this service at competitive prices.
And coming back to the employees who were doing the work here, well, as we noticed, we worked both on the roofs and with, let's say, with electrical work. Maybe not on live circuits, but with electrical wiring. The work of electricians, well, I think everyone also has to be suited for most of these tasks.
Yes, and that's what I started telling you about, that we do some of the work, we do mechanical work, yes, meaning we build steel structures. These people should be properly trained in the use of power tools, safety procedures, and occupational health and safety. But we also have the electrical part, and we require our employees to have the proper qualifications, meaning the so-called SEP certificates for operation. Here we don't operate at voltages higher than 1 kV, so SEP certificates up to 1 kV are accepted. An employee who is trained and properly certified can start working.
Okay, so dear viewers, if you would also like to take advantage of this and become an electrical fitter, now you know what the rates are, how to get such a job and how to do it. Most importantly, that's what we showed in today's episode. If you'd like to see other interesting content, let us know in the comments. Thank you so much. This material was excellent.
That you came to visit us.
On one hand, it's about photovoltaics, and on the other about these modern and new technologies that we haven't shown on the channel for work yet. For me, these energy storage systems are something great, that we don't just have to sell this energy, we can use it ourselves and, let's say, offset our own consumption. So that's great. And the other thing, well, these carports, I also think it's cool that we can put something more aesthetic in front of the house to use solar energy and protect our car when it doesn't fit in the garage. Great, of course, give this video a thumbs up, comment just like I asked you before, and subscribe to the DuroBody channel because I know not everyone is doing it yet. This is Wojtek Kaczmarczyk. I'm glad you made it to the end. Thanks for watching, and I encourage you to check out more videos on the DuroBody channel. See you next time. Click the next video to see what interesting things I recorded.